Hello everyone, my name is Dr. Digvijay, and in the today's lecture I am going to discuss about a very important question of the solid state physics, that why semiconductors act as an insulator at 0 Kelvin. So these are the learning objectives of the today's lecture. So let's start the today's lecture. To understand the classification of the materials based on the band theory, first of all we should be aware of that there are two types of the bands. One is valence band and the other is conduction band. And when we classify the materials on the basis of band gap and the basis of conductivity, then generally we talk about the three types of the materials in general. First one is the metal and semiconductor and insulator. Then what is a valence band? Valence band basically comprises the valence electrons, and there is also a band named conduction band, which has lots of free energy level. If we talk about the situation at 0 Kelvin, the valence band in each of them, like in metal, semiconductor and insulator, is completely occupied at 0 Kelvin, and the conduction band is completely empty. Means lots of free energy states are available inside the conduction band. And the gap between the valence band maxima and the conduction band minima is called the energy gap. And if we want the material to conduct, then the electron must be raised from the valence band to the conduction band, because if the electron will reach in the conduction band, then it will see lots of free energy states, and now it can move freely. So in case of metals at T equal to 0 Kelvin, the band gap is nearly 0, means the valence band and conduction bands overlap. And in case of insulators, this gap is very large, approximately greater than 3 electron volt. And in case of semiconductor, this gap is of the order of 1 to 2 electron volt or 1 to 3 electron volt. So let's talk about the state of a semiconductor at 0 Kelvin. So we are considering the example of a silicon or germanium. Silicon has 4 electrons in its outermost orbit, so it gets bonded with neighboring silicon atoms as shown in the figure to complete its octet. Means each of the electron is bonded with the neighboring electron of the neighboring silicon atom. Means there are no free electrons for the conduction, and as we have talked that there will be conduction only if there are free electrons present, but each of the electron is involved in the bonding, so there are no free electrons, and hence semiconductor behaves like insulator, because in insulators also there is no conduction since it has no free electrons to conduct. This is basically the bond model. And if we talk about the band model, then at 0 Kelvin, like the insulators, the valence band is completely filled and the conduction band is empty. And as we have discussed that the conduction will take place only if the electron is present in the conduction band. Since conduction bands have lots of free energy states, so electron can move freely. But at 0 Kelvin, valence band is completely filled and conduction band is empty. This is the situation like insulator, where also there is no electron in the conduction band and valence band remains completely filled. So we can say that at 0 Kelvin, the semiconductor behaves like insulator. But if we increase the temperature, then some of the electrons from the valence band may be raised to the conduction band, and if they reach in the conduction band, they will see lots of free energy state, and now they can move freely and will conduct well. Okay, so uh, in conclusion, we can say that since no free electrons available in the conduction band to move, the semiconductor cannot conduct electricity at 0 Kelvin and behaves as a perfect insulator. Okay, thank you for your kind attention, and if you have any questions, you are free to ask them in the comment section. Thank you.